challenging question for you, Raf and Isaac. How many objects do you see I have hanging on the rope?
Three.
Can you clarify what three objects you identify?
Well, there are two strings and there's a mast between them attached to both.
We're gonna make a convention. We're gonna call this one rope one, we're gonna call this one mass, and we're gonna call this one rope two. It's gonna be a little
Remember
bit
that,
challenging.
Ref.
It's gonna be a
5
little
words.
bit
I know it
it's
can
gonna
be
be a little
hard.
bit challenging because this is not what something they teach at college. We only cover things that they don't cover at college. Okay, now I'm gonna write two scenario and you're gonna tell me which scenario will do what to the rope. This is 200 gram. I'm gonna have acceleration due to gravity. Do you have a calculator? Yes or no?
Yeah, I have
Yes.
one on the computer.
Isaac is okay. I'm gonna use -10.
I have one. I have one.
I have one here.
So -10. Okay. Okay, -10.
Yeah, okay.
And I'm gonna say F pole is -5 Newton down.
Okay.
And I'm gonna say T is for scenario 1, 0.000001 second. How much is it?
That's very low seconds.
How much?
10 to the minus
10 to
6.
the-
One what?
One
One
millisecond,
microsecond.
microsecond.
One microsecond. Good.
Cheater, copier,
Okay.
stealer,
Scenario 2.
Okay.
Shh.
cocoon,
Scenario 2 mass
crooked clown.
200. Gravity is still -10 because yeah, we are here on the Earth.
Mm-hmm.
Wow, I didn't know that. I thought we were on Mars.
F pole is -5 Newton at the y direction. And T is 1 second. If I pull spending 1 microsecond, which rope will break? Write it down.
Rope 1 or rope 2?
Yeah, write it down. Don't say.
Okay. Can we calculate anything or just
No,
guess?
no. It's not the calculation. Go ahead, write it down.
Okay.
No, it shouldn't take that long.
Okay. Okay, I'm gonna guess.
Stupid.
Okay, I just wrote it.
Okay. Isaac, let me see what you wrote.
Do you see what I wrote, Dad?
I see rope 1. Isaac, what did you write?
1.
Okay.
Wait, you copied me.
So
Die.
it doesn't matter. Both of you are losers, so it doesn't matter.
Wait, what?
Yeah, it doesn't matter.
Really?
Okay, so you're gonna see that what happened.
Uh-huh.
The second scenario, right? The rope 1 will break. The first scenario, rope 2 will break. In fact, the mass will not even know that someone pulling the rope 2. Mass even will not know
T is
that
1 microsecond, it will break.
Yeah. So
How?
mass will not even know that someone is pulling the rope 2 by applying a -5 Newton because it happens almost in 0 second. 1 microsecond is almost a 0 second. In real life scenario, if you have a glass of water and you have a paper underneath glass of water, if you pull the paper, the glass will not know even when it loses the ground.
That makes sense.
Good. So why it was so difficult, why a graduate student and undergraduate student both got wrong.
So
I'm
you're
stupid.
pulling you're pulling the mass, right?
No, I'm pulling the rope number 2.
Okay.
The object is at rest. It's Newton's first law. We all agree?
Yeah.
Yes.
Okay.
So-
If I spend 1 second to pull the rope 2, then rope 1 will break. If I do it almost instantaneously, which is 1 microsecond,
Ready,
set, go.
set, go.
I didn't see because
it's broken.
okay.
It's broken.
Oh.
Now, I'm going to do now scenario number 2. I'm going to take forever to what? To pull it.
pull it up. Okay.
I'm gonna
Please
take
show
forever
me
to
what
pull
you
it, and
wrote
you'll
on the
see what
blackboard.
happened.
Mm-hmm.
And when you do free body diagram, see, everything is broken. See, everything is broken. Now I'm gonna do free body diagram. What gonna you see? You're gonna see.
Can you please show the board behind you?
See it now.
Okay. That's the same thing except you apply it for longer.
Ready?
Yeah.
Who want the countdown?
Ready, set,
Set,
go.
go.
Well, I'm
Now.
gonna take forever. I'm not gonna say ready, set, go. I'm gonna cut forever.
Ah, I see.
Wow.
Okay. Wow. That's
Dad,
interesting. Yeah.
Draw the
Look.
free body diagram on the rope too.
Okay, so rope 2. Well, I mean, it should be pretty simple. There's a very small force of Fg, so we basically don't need to account for
Did I
that.
say that there is no rope has no mass? Did I say that?
No.
Okay. Yeah, that's it. I drew it.
That's wrong.
Ah.
Mass
Oh,
did not
yeah.
know that there is an applied force.
No,
That's
this is not the mass. This is the rope. There's an applied force on the rope.
That's it. The rope, yeah.
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 I see you have a force up.
No, this is the only force, applied force.
So what is that up?
This is the top rope. This is the bottom rope.
Why your force body doesn't draw rope, baby?
No, you said to draw.
He's
free
saying to
body.
not draw everything together. Make separate free body
Free
diagram.
body diagram means you
Oh.
don't draw rope.
Okay. Oh, okay, then it's just this.
Okay, that's it. Now, can you draw the mass? The force on the mass. How many force acting on the mass?
Well, there's the force of
Yeah.
gravity. There's no force from the pull, but there's definitely a force of tension.
Uh-huh.
And can you put the value? Put the value.
It's the same as the force of gravity. Otherwise, it would fall.
Did you put the value, Raf? Use -10.
Yeah, sure. I don't know the mass of the box.
Shut up. You don't need to.
I gave you 200 gram.
Oh, okay, I didn't see that. Okay,
These
so
are important. In a few seconds, put those 3 free body diagram next to each other because we're gonna explain the motion. The first one, then
Okay.
second one, then third one. Put them in one row. Put them in one row. First one, second one, and then third one. Okay. Now, can you draw what did you write? I cannot see. 2 Newton, 2 Newton. Good. -2 Newton, +2 Newton. Very good. Now, can you draw the free body diagram on the rope number 1?
Okay. Okay, there is just okay.
Rope 2.
Yeah.
Did you do rope 2?
No, I did rope 1.
Or rope 1? Rope 2, mass, rope 1. Yeah, how many forces?
There's just one.
No, 2. Isaac, how many forces did you draw?
2. There's one from the block pulling it down, and one from the ceiling pulling it up.
Good. How
From the
much?
ceiling? Wait, from the ceiling? What?
The
How
thing
much
that
is
the
the
rope is
one?
attached to on the top.
You usually don't draw that.
You do.
Okay, ref, if there was no ceiling, there would be no upward force. and
Yeah,
the rope
but
would fall
I've never
down.
seen a free body diagram where you draw the force the ceiling is exerting on the rope.
If there was no force of the ceiling, then the free body diagram would say the string is falling down. But that's obviously
Yeah,
not the case.
obviously I know that, but
So 2 Newton down, 2 Newton up.
Yeah.
okay, if the rope is massless, why does the ceiling have to exert a force?
It's not actually massless, ref. And also they have to
Okay.
exert a force because of this thing attached to it.
If you
Okay,
cut
I don't-
the rope by scissor, right?
Think about it, ref.
If you
If the
cut the rope by
string
scissor,
has-
then there is no tension.
Dad!
Okay.
If the string has a mass attached to it and nothing pulling it upward, it's going to act as if it's part of the mass. It's gonna fall down with the mass.
Okay, but we're assuming the string is massless, right?
That doesn't change anything.
But you
If the
just
string is
said that the
massless and
force that the
attached to the
ceiling
block,
exerts only acts if the string has a mass.
what?
You said the force that the ceiling exerts only exists if the string has a mass.
No, I never said that.
So if I don't understand why the ceiling would exert a force if the rope is
Because the
massless.
block or the mass, whatever, is still pulling down on the rope. The rope is acting like it's a part of the mass. If you cut its connection to the ceiling, no matter if it's massless or not, it's going to fall down with the actual thing that has mass.
Okay, fine. So you're saying there's a force of the ceiling on the rope?
Yes.
Now, can you
Okay.
do me a favor? Can you put these three in the same box?
Why, God?
Then we take a look and we
Also,
know why the rope 2 broke.
why doesn't the applied force show up on rope 1?
Because
I
mass
guess we-
even didn't know someone pull. If mass didn't know someone pull, then how rope 1 would know that someone messing up with rope 2?
Can you stop
Okay.
using anthropomorphic language? You don't have to say the rope doesn't know. You can just say the rope is not affected. It makes it less
No, I
confusing.
said that mass did not know someone pulling it down
I
because
said, please don't anthropomorphize these objects. It makes it more confusing.
So how would you say it?
I would say that the pull on rope 2 doesn't affect the mass.
Okay, but that's saying the same thing.
I know, stupid. It's just saying it in a less confusing way.
Actually, it makes it more confusing.
Are you retarded?
okay, we have only 10 minutes. Can we finish it? Can you tell me why the rope 2 broke and not 1?
Okay, well,
Yeah, because that's
hey,
only
shut
one that
up.
has an unbalanced force.
Yeah, rope 2
So
only has a pulling force. There's nothing keeping it upward. The mass is not pulling it up like the ceiling does. But the mass has a balanced force, and rope 1 has a balanced force. So rope 2 is cooked.
Fast law. The mass is Newton fast law, but rope 2, unbalanced force acted on rope 2. That's why rope 2 broke. Now,
I just said that.
let's do the second one now. Okay, and what is the value, Isaac? Tell me.
5 newtons downward.
5 unit downward, and then on the top,
What's the top force coming from that wasn't there before?
5 Newton up, 5 Newton down.
Can you explain why it's there when it wasn't before? The tension?
Good. This time it took forever, 1 second or maybe less than 1 second, who knows. The rope did have time to communicate with the mass.
Oh my God, they are not people. They don't communicate.
If you have a paper underneath of a glass that filled with water, and if you take forever to pull the paper,
That's just saying another phenomenon. It's
That's
not
right.
explaining why it happens.
that's right. So then I'm gonna use the physics to say it. I'm gonna say then the friction get the time to react. Then I'm gonna
That works, sure.
So
you can
now-
imagine, like, when you pull on the rope, it's like a wave traveling up through the.
Oh, think
Oh,
about
that
this.
makes the most sense. Because when you pull on it slowly, pretty much
Maybe.
everything in the system is affected.
Baby, think
Yeah.
about this. Do you still remember we went to Canada like middle of the night?
Can you stop giving examples and
No,
start
no.
giving explanations?
If 5 centimeter above, if 5 centimeter in front of my car, a deer run, would I be able to react?
No.
If 50 meter in
But
front
Dad, problem.
Mhm.
Objects are not people. They don't have finite reaction times.
analogy,
like our eye.
analogy. Okay,
Doesn't make sense.
mass. Can you do the mass? We have 1 minute. Mass.
Oh, yeah.
No, we actually have 6.5.
Okay.
Put the value.
Okay.
So essentially, when you pull on the rope for so long, you're kind of starting to pull on the entire system. Whereas when you pull on the rope for a very short time, it's not part of the whole system. You're just pulling on the rope independently.
You know what I did? I wanted to dig it further, so I tested it with a glass of water and paper underneath just to see that it hold, and it did.
Uh,
Okay. How many forces down?
What, on the mass?
Yeah,
Well, there's the force of
I-
gravity and, well, the force of the pull.
that's right. Two force. They have two
oh,
force, right?
yeah, I was thinking what the second force
Die!
would be.
How many
Yeah,
up? How many up?
just
The
one.
force of tension.
How much?
10?
7.
Oh.
5
Oh,
plus
yeah,
2.
that makes sense because FG is 2. I thought it was 5 for some reason.
Okay, now can you do rope 1?
Well, rope 1 now has the force of the pull on it
Okay.
directly. It has the force of tension because it needs to support
You
the
have to
mass.
put the number, baby. Put the number.
Okay, yeah, I will. Okay.
And its only support up here is still 2.
Okay, I think. Yeah, I
So
think
what is the down, baby? Big baby?
7
7.
Newton.
And what is the up?
2.
Good. Oh
Where
no.
did you
Down
why?
is 7, up is 7.
So why does it break?
I wrote something in the board. Can you discover that?
What?
Its limit
I
is
can't
7
see.
newtons.
Everything has a limit, right?
The rope ran out of tension to give.
That's right. So why then rope 2 didn't break?
There was less force on it, so it didn't hit its tension limit.
What? Okay, I'm confused. What do you mean there was?
The rope 2 only has to support 5 newtons of
No,
tension.
all rope, not rope 2, all rope. All rope. Rope 1, rope 2, both 7.
Yeah, no, rope 1 and rope 2 both have a tension limit of 7 newtons. Rope 2 only
Okay.
needed to use 5 newtons of its limit. Rope 1 had to
Yeah.
use 7 newtons, so it broke. It couldn't take the tension.
Okay, because rope 1 also has to support a mass. Rope 2 doesn't have to support a
Yes.
mass. Okay. Ooh. I don't understand where this 5 newtons is coming from on the block. Yeah, no. This is a tension force though. So
Yes.
if the rope can only pull, then how is it pushing here if the rope is underneath?
It's not pushing, it's also pulling.
No, but
If the rope is
that's the rope on
underneath,
the top.
the rope is underneath and it's dragging the block down. That means
Yeah,
it's pulling.
but that doesn't make sense because the ropes can only act on something that's underneath them. The rope can only
No
pull.
rope is pushing, baby. No rope is pushing. All the time rope is
Wait.
pulling.
Yeah, so where is this tension force
Ref,
coming
think
from?
about it. If the mass is like this, then it will pull upward. If the mass is like this, it will pull downward. In both situations,
No, but the second situation is not possible. A rope cannot
hand off a mass.
pull downward.
Who told you that?
Ropes can only pull upward. It can only support a mass. It cannot.
Can I show you an example? Let me show you an example. Atwood machine, right?
Uh-huh.
Which way it is accelerating?
Well, the bigger block is on the left, so downward to the left side.
What is the acceleration over here? Positive. What is the acceleration over here? Negative. But the tension is both sides is positive. The tension over here is positive and over here positive.
Uh,
So rope doesn't actually push. The tension both sides is positive.
Okay, yeah,
It's
okay,
over.
that's a good explanation. Yeah. Okay, in both cases, the tension is acting up.